go ahead, Eric.
Very good. Thank you, Derek. And thank you, Niraj, and thank you to the Charlotte Microsoft Azure user group and the meetup. We're excited to share this story with you this evening. So I guess real quick, Derek, if you want to go to the next slide. Niraj kind of covered this, right? But for those of you that don't know, so CEI, it stands for Computer Enterprise Incorporated. We're headquartered in Pittsburgh. We've been a Microsoft partner since 2004. And Derek is one of our solution architects. So he's part of our custom solution team, really focused on agile DevOps, modern cloud, modern data platform technologies to help customers transform and really embrace that technology. I've been with the organization only about 3 months, right? I've been in the Charlotte region close to 13 years, but all of my time has been, selling, professional services for packaged applications, custom applications, and helping companies achieve what they can with technology. So if you want to jump to the next slide, why we're talking to you tonight, right? Why customers care, and then more importantly, why clients, need to care about their customers. Derek will lead a conversation around the customer data platform, all of the components, and they're all Microsoft components that contributed to this solution. He'll jump into a demo, and then we'll wrap things up, right? We'll maybe share a little bit more information about CEI, but really want to dive into some Q&A. So, why customers care, and it's like, why customers care to, that product company or service company, right? And rather than read off, each of these bullet points, but the fact of the matter is, there's surveys out there, by leading, marketing companies. 89% of consumers expect, almost demand that product company know them, right? Have some type of personalization, some connection to that customer, so that they understand, buying habits, kind of that Netflix phenomena, right? Like that next best choice. You watch these movies, these TV shows. There's a good chance you probably like these other shows, but it really grabs into that product company, that consumer goods company, understanding what their customer, what drives that customer behavior. If you want to go ahead and go to the next slide, we use this, we borrowed this from Microsoft, but it kind of paints the picture, where all of this customer data is coming from. And obviously, loads and loads of data, transactional data, point of sale data, behavioral data that can be scraped from, social media or, customer loyalty programs, understanding customer preferences. So all of that information, all of those, little bytes of data, right, need to be stored somewhere. And then obviously, you need to be able to run some analytics to get insights and to then really personalize and know who your customer is, so that you can, have that, quote unquote customer for life, right? And I think that kind of wraps it up for our intro. And we'll jump right into our case study, right in time for the dogs to bark.
So I'm gonna walk everyone through tonight what a customer data platform is in Azure. And we use the term customer data platform, but really it's a cloud data platform. It's something that can be used across many different cases. Any place where you need to be able to bring in disparate data into a common data analytics system would benefit from a cloud data platform in Azure. So I'm just going to walk through some of the platform elements and kind of the technologies and some of the design choices we made in developing a data platform for a retail organization. So really the foundation of it is the enterprise data lake. A lot of organizations, they typically have a data warehouse, and those can become costly to maintain, and it's very difficult to ingest new data sources. There's a lot of upfront curation that needs to be done. So that just adds to the lag time between when data comes into the system and when it's ready for analytics by a variety of people in the organization. So this is transitioning to more of an enterprise data lake is the foundation, and that data lake can handle all different kinds of data, whether it's structured, unstructured, IoT data. It's able to handle the volume and velocity of data that's common in today's organizations. And then from there, you use various data orchestration tools to build ETL processes to really curate that data into a set of good data products. And what I mean by a data product is it's a product that of data that is that's well curated. It has a defined schema. It has a defined SLA, so you know when it's updated. It's properly controlled. It's properly secured. And so you need good ETL tools in order to build up those data products. And those data products need to be made available to the organization through some data cataloging technologies. And so it needs to be tightly controlled. You're going to have multiple consumers of the data product in an organization, and you really want to make sure that it's reliable and has a good SLA behind it. And then, it's not, you need, for a data platform, you really need to have a powerful insights being pulled from that data. So this is where you can bring in things like machine learning. You can bring in tools like Databricks, like Niraj mentioned, and then you can really use Power BI to help provide reporting and dashboarding on top of your data platform and your data lake, and any other data warehouses or data marts you may build up the data lake. So some considerations that we had for when building a data lake is you really need to have a robust data ingestion, data ingestion framework, so you can pull data in from various data feeds. And those data feeds could be internal, they could be external, they could be housed in legacy systems, or they can be coming from SaaS-based cloud services. So for data ingestion, we typically use things like Data Factory or Databricks. And then next thing, the most important thing is security. So we leverage Azure RBAC and managed identities where possible. In fact, we try to always use managed identities throughout. So we have that zero trust model going on within the data lake, and try to really limit the username and password authentication that's required. Of course, if you need to use username and password, there's Key Vault to store those. And then as far as networking, some organizations, they have, let's say a lot of organizations have networking between their on-premise environments up into Azure. So you really want to put your resources in a VNet, use things like VNet injection, private endpoints, so that access to some of the services is over private endpoints that are properly controlled. Next is automation, and automation can come in two forms. One is the automation of the data pipelines. So you want to make sure that those data pipelines are scheduled to happen when new data arrives, or maybe maybe they're scheduled once per day, or they need to run every 15 minutes and pull the latest data from the past 15 minutes. So you really want to have your data pipelines be event driven, and in order to avoid those scheduling type scenarios where you have scheduled pipelines running, you may not know if the previous one was successful. It could kind of turn into a mess pretty quick. The other side of automation is from a DevOps perspective. So you're building up this data lake, you're building up these pipelines and all these different resources in Azure. Well, you really need to automate that. You want to use ARM templates and PowerShell in order to automate those through release pipelines in Azure DevOps. And then that way you can deploy it to multiple different environments. So if you have different lifecycle environments like dev, test, QA, and prod, you can automate all that. And you can limit, with the automation, it ties into security. You can really limit what the DevOps team has access to within Azure. So, is there a question? I'm sorry. Anyway, so yeah, automation, it kind of ties in security. You could have your DevOps teams only have read-only access to your Azure environment and simply rely on DevOps to deploy and maintain all the resources. Next, you need monitoring. There's lots of moving pieces inside these data platforms, so you really want to have good monitoring put in place. So you want to look for things like failed pipelines, but also you want to look for missing pipelines. If you know a new data set is supposed to come in every 24 hours and you haven't seen it in 30 hours, then you may want to alert someone to let them know that, hey, we didn't get a new data set. Of course, analytics. You want to be able to perform good analytics on data that's in your data lake. So that's where Azure Synapse and Azure Machine Learning, and then using tools like Spark and HD Insight, that can really help you out as well. And then reporting, there's all kinds of different reporting tools out there, whether it's Power BI or some other ones, but this really provides the face of the data lake to a lot of folks within the organization. A lot of C-level execs like to see data that's been joined together and insights generated from those disparate data sources to provide some information that wasn't previously known. So if we look, I mean, this is the high-level architecture of all the different services that are in play in a data platform in Azure. So on the left, we have the different data sources that can be brought in. I mean, you may be bringing in data from an enterprise data warehouse or another database, and those databases, they could be on-premise, or they could be living in Azure, or they could even be in another cloud. But then there's also structured data sources. So you may be pulling data from files or from external services. So maybe you're bringing in clickstream data, maybe you're bringing in some other digital marketing data, or even some sales data from Square or some point of sale systems, and then unstructured data sources too. So that's your plain text files, that's your images, video, that sort of thing. And then ingestion, you're going to use Azure Data Factory for some of that batch style ingestion, or you can use Stream Analytics to capture an incoming stream of events. And then all that goes into the data lake. And within a data lake, there's a couple different conceptual zones of a data lake. So typically, conceptually, they organize them in the bronze, silver, and gold. So bronze is your raw data. That's where all the raw data feeds. That's where it lands data. And sometimes this data isn't readable, and it needs further curated in order to make it at least readable. Sometimes you have it where there's no schema defined on those files, or it really needs cleaned up. So, and the idea for the bronze zone, for that raw layer, is that you want to store everything you can, right? So you want to configure lifecycle policies on that data so that it's archived after 30 days, and so it doesn't cost you more to store it. But then from there, you want to process the data. So you want to take the data that's in the bronze zone, and you want to build good data products from it, and you want to store those in the silver layer. And you'll use tools like Azure Databricks or Azure Dataflow or Synapse, and you'll build up those data products using those tools. And you can even use Azure Machine Learning to kind of get some insights from the data, and then publish that out as another data product. And then you need to be able to serve, in some cases, serve up the curated data products to other parts of the organization for consumption. So that could be reporting applications or other focused applications like mobile apps, or even some Power Platform apps. And there's a couple different ways you can serve it up. You can serve up smaller data marts in SQL database, or you can build out an enterprise data warehouse in Synapse, and use a traditional data warehouse technology to feed into some of those reporting and application systems. And then data platforms, they typically work good if you have a good DevOps process behind it. So that's doing things like maintaining backlogs, maintaining infrastructure as code, and then using release pipelines to release out or to configure the environment appropriately. And obviously that monitoring, so it's good to have dashboards showing the status of the data platform, using Azure Monitor to send out alerts, and then using log analytics to capture various diagnostics from the components and possibly alerting up those as well. So one of the things when building up a data lake in an organization, particularly large organizations, is they kind of fall into two different categories. One is a centralized data lake, and the other is a distributed data lake. And with a centralized data lake, you typically have units that are feeding data to this centralized team. And this team is the one that's maintaining all the ETL pipelines, and they're the ones building out the data products. So this, within large organizations, it becomes more challenging. So serving that data from a central location can become challenging, mainly from a data organization and security point of view. Typically, when this happens, it turns out to be a data swamp where there's a lot of data out there. It's tough to secure. There's blurred ownership, and there's often a lag in when new data comes in to when it's actually available to consumers due to if there's been any requirements of data changing. This centralized team needs to become reacquainted with that data in order to build out these data products. But on the flip side, if you have, in a large organization, if you have various business units, maybe those business units are your digital marketing team. It could be your team that's maintaining your point of sale equipment. It could be the team maintaining your master list of products, or it could be your CRM system. Those are typically maintained by cross-functional teams. So those data products are owned by small isolated teams, and they have the domain knowledge to build out those data products. So your point of sale team that maintains those systems knows the most about that data, and they know how to properly curate it into something that's usable for the rest of the organization. And what ends up happening is that you're building up a data mesh where business units can depend on other business units' data products in order to further refine data products or generate some insight from each business unit's data. And then each business unit, they can have independent backlogs and release cycles. So this typically follows Conway's law, if you're familiar with that. So you want to organize your data lake according to how the business is organized. And that's one of the decisions we kind of make up front when we talk to organizations about building up a data platform, is how are their teams organized, and how do they currently maintain their data products? How do they maintain their enterprise data warehouse? What's the role of the enterprise data warehouse in the organization? Some use that as the de facto source of knowledge for the entire organization, and others use it more just for reporting and relying on other systems as the system of record for certain data sets. So as far as the data lake, I mean, our goal is, extensible data lake platform. It has clear data curation and ownership responsibilities. It provide governed access with identifiable and unique service level agreements for each business unit. So what we do here is we use Azure Data Lake Gen 2. So it's based on Azure storage and blob storage. We divide that up into conceptual data lake zones, bronze, silver, and gold. And then we use standard RBAC, mainly Azure AD groups and permissions, in order to control access to the data products in the data lake. Data ingestion, talked a lot about Data Factory. So Data Factory can be configured to do event-based processing and scheduled triggers. So you can pull data from all sorts of different data sources: RDBMS, file share, click streams from, in this case, it was Adobe, any other type of data source. Data Factory has a lot of different connectors to connect to a wide variety of sources, whether it's on-prem or in the cloud. And the idea here is to get it into the bronze zone, and then use events then to further process it into silver and gold layers. And in some cases, we use Databricks to do some validation of the data and to further curate the data. using some of the PySpark technology within Databricks. With analytics, we want to provide dashboards and reports to a set of various BI users across an organization. So, we have all these feeds coming into the data lake, and then from there we use Data Factory with data flow in order to build up a Synapse data warehouse. And the Synapse data warehouse, if you're not quite familiar, it's really just a rebranded SQL data warehouse. They just took that and rebranded it to SQL data warehouse, and then they added some new technology on top of it called Synapse Workspaces, and that's a preview right now. And I'm going to talk about that here in a little bit and show some demos on Synapse. But Data Factory and Data Flow, it's really building up a star schema that goes into the data warehouse, and that's feeding into dashboards and reports, and those are in Power BI or other reporting tools, and it's being served out through the organization. It's typically business intelligence users, and then C-level execs use those dashboards and reports to get some insight on what's going on within the organization. So Azure Synapse Analytics. So this is currently in public preview. It's really taking a lot of the data analytic technologies that are within Azure, and it's kind of provisioning it, or not provisioning it, but wrapping it into a nice user experience called Synapse Analytics Studio. So it's bringing in all the data integration tools from Azure Data Factory, and it's using Azure Data Lake Storage as the foundation of all the analytics. So you have different analytic runtimes. You can use traditional SQL, or you can use Spark. And then there's different ways you can access the data within the data lake. You can use what's called provisioned databases, and that's where you're using SQL Data Warehouse. So that's, you're spinning up an actual database server, and you're putting certain resource constraints on it, such like data warehouse units. But on the flip side, you have on-demand, which is kind of nice. I'm going to show on-demand later on in the demo, but basically on-demand gives you SQL access to files in your data lake. So you can write SQL commands against files in your data lake, just as you would database tables, but it's all serverless. So you're being charged by the amount of data being processed by the query, and not necessarily by compute units or anything like that. Languages, it supports a wide variety of languages. And then it has the typical management, security, monitoring, and then it has a Hive metastore too for integrating Hadoop-based workflows. So it's really that Synapse Analytics Studio is wrapping all of the different technologies and services within Azure for data analytics, and wrapping it into one nice user experience to really make it like one-stop shop for any analytics. Security, obviously you want to enforce best practices. So you have different components going on here. You want to try to leverage managed identity as much as possible, and using your Azure AD credentials whenever the user is actually using Databricks workspaces or Synapse or accessing data on the data lake. You want to really use pass-through authentication with Azure AD. And then when you have service-to-service communication, really you want to rely on managed identity. And if you can't use managed identity, fall back to service principals. And then a last resort, especially when you're talking with some legacy databases or things like file shares or FTP sites, sometimes it's just unavoidable to use username and passwords or username and certificates. So in that case, you want to put those into Key Vault. And then Azure provides out of the box encryption at rest and encryption in transit when storing data in your data lake. So it's important to, they do handle both customer managed keys and Microsoft managed keys. So you have the option for customer managed if your organization requires it. Monitoring, I talked about monitoring some before. So really you want to configure diagnostic log shipping to Azure Log Analytics. You can run custom queries for, to query the log analytics and alert if anything doesn't seem right. We used it for missing pipeline runs, or If you're expecting a pipeline to run every hour and it hasn't run within maybe 90 minutes, then you want to alert someone. So one thing too is establish alerting standards, naming conventions, severities, and distribution lists for your alerting as well. Automation. So yeah, we want to do we want to make sure that the deployments are automated. So we're using various Azure DevOps source control and release management. So we release pipelines and then we also use Data Factory's Git integration. So when you're developing your pipelines within Data Factory, you can save all your edits to a Git repository and then use those in your release pipelines to deploy those out to the other environments. And then it helps to have a library of custom ARM templates to help you spin up the various resources like storage accounts. It's nice to have a good set of gold standard ARM templates to help build out environments. And then obviously governance and documentation. When you have that distributed data lake team, you really want to break out the individual business units into their own Azure subscriptions. That way those teams can remain autonomous. They're not going back to IT for every change. They can manage their production environment. So a lot of organizations have a philosophy of you build it, you maintain it. And then you want to have good architecture designs around dev, QA, and prod environments, what they're going to be used for, the type of data that'll be in them, how much data will be in them, and some other good practices. You want to have formalized naming standards for all your Azure resources. Your organization may already do that. That's pretty common, but it's really important when you have a lot of resources that you want to have a good naming standard for those. And then establishing good DevOps and operational pipelines is important as well for governance. Okay, with that, I was going to jump over into doing some demos here. Is there any questions from anyone before I start?
I have a question around the distributed setup. You mentioned that was loosely coupled and that data should be managed from an event-driven perspective. And if that's done, how would you make releases timely, given that if various groups are able to manage data, define how it's transformed, and then other groups would then be consumers of that data, how would you maintain the ability to release in a pretty timely manner without having so many dependencies, it seems? How does it remain loosely coupled?
So there's a few ways to do that. So one of the things that we found is that you define your specifications of your data products, and let's say you have a V1 data product, and you have pipelines built to build up that data product, and you're going to stick to that version. You have to commit to that version, so you got to make sure that version is correct. But then let's say you get some new requirements and it requires breaking changes to a data product, in which case you may want to go to a V2 data product. So at that point in time, you have to decide, like, okay, what do I do with V1? I mean, you may have to just keep updating V1 because you have so many consumers on it while still supporting V2. So you have a case where you're maintaining two different versions of data products. So that way, when you're doing that, then you're keeping those end consumers happy, but then you're also helping out some of the new consumers that are requesting V2. Does that help answer your question, or?
I'm seeing what you're saying is that though you are curators of the data, you have versions that support downstream needs, and depending on the amount of downstream dependencies on versions of the data, you would have to maintain it, or you could, of course, sunset versions based on not being needed in the future. Um, okay,
Right.
I get that.
Right.
Thank you.
Yep. No worries. And there is some technology out there that we haven't leveraged yet, but are interested in using, and it's Azure data sharing. And so what that means is, let me go back a little bit to this one slide. So, if you have each of these business units, each having their own data products, you can configure Azure data sharing to control access to those data products to other business units. And there's different ways you can do it. You can do it where you're doing a full copy of the data, so it'll do a full refresh over to this other business unit and then set in incrementals, or it will you just do a share in place, and then that way you're letting Azure really control that access um, to the data products, where you're not really having to go in and maintain RBAC or maintain group membership. It's controlling all that for you. But then also you can take that data sharing concept and share it with an external entity, or maybe a business partner. So that's one of the things that we haven't used yet, but are interested in learning more about, in order to share data between different units within an organization. And that may help too, as far as maintaining different versions of data, and maintaining an SLA as well.
Absolutely.
Any other questions?
I kind of have a follow-up question.
Sure.
Are you familiar with domain-driven development?
Yes, a little bit.
A little bit. And given some of the things, like you said, standardize the terminology that you have there, could you speak to how much Azure DevOps could be used in terms of sort of what domain-driven development typically means?
Yeah. So when you have I'll answer this the way we kind of work through it, is that when you have different teams maintaining their own releases and maintaining their own environments, really, we have this concept of kind of like a shared nothing approach, where each subscription is living independently. Um, while those subscriptions, they can be governed by a corporate policy, they're really maintained by their DevOps teams. And those DevOps teams are maintaining the data products, and they're maintaining all the resources within Azure. They're doing all the monitoring, all the best practices for maintaining a platform within the cloud. So really, we want to make sure that we have separation of concerns, that we're not getting into that centralized approach where everything's being dumped into this single data lake for it to become unorganized, and now security becomes challenging. You got to funnel everything back to a single team, versus going to the team that is actually maintaining the data, and has the most domain knowledge about that data. And then, if you, like I mentioned with data sharing, you can really start building up some anti-corruption layers around that data, so you're not dependent upon um, a certain schema. So you could take a V1 data product, conform it to your own needs, and you can have that as kind of like an interface layer, so you don't incur any corruption within your data products from any other products that you're depending upon.
Okay, thank you.
So the question was like, how do you use, how do you apply domain-driven design to the data lake solution, or what was the?
So I was mostly getting at, with domain-driven development, it usually entails sort of a micro strategy, and
Yep.
so it really it demands that you manage your data very strictly, and there's typically not a lot of sharing with the data, because each
Bounded.
team would maintain its own products, and so very um, very much so that they're managing it, and there shouldn't be a lot of interdependencies and things like that, because it then defeats the purpose of being able to release in a very timely manner when, coupled so many dependencies, waste, delays, and things like that. And so you don't have the ability to release as you would like to or may need to based on what you're doing. And so the versioning he describes it allows you to have that independence um, going forward. Yes.
Yeah, and you can think of the versioning almost like you're versioning an API. Now, the API in this case is basically Azure storage, but you're really governing what's in those files that you're pulling from the data lake, what the schema is, how they're structured, how they're partitioned, and if you have to really keep track of, to make sure things aren't going to break downstream by making what could be a simple change. It's where versioning of data products really comes into play here, much like you would version an API.
Yes.
Yep.
That's a good question.
Yeah, that was a great question. Okay, so I was going to jump into a demo if there's no other further questions. And the demo, I'm just really going to focus on Azure Synapse, kind of highlighting some of the features in it. And really, I'm not going to use real customer data. I'm going to use some stuff from some of the sample data that Microsoft provides, AdventureWorks, and all the stuff that we can use when we create databases and we need to do any experiments or do some prototypes, typically using that type. But so right now on the screen is a Synapse workspace. So this is Azure Synapse Analytics Studio. So this is kind of bringing in all the different services from Azure, Data Factory, Spark, giving you like a kind of a Databricks environment. It allows you to explore your data lake. It allows you to develop data flows, SQL scripts, Spark jobs, and Spark notebooks, and then it then allows you to do full monitoring of all the pipelines and scripts and everything that's in your workspace. So dive in here a little bit. So on the left, you have your different areas, your data. We can explore your data, develop. That's where you can develop SQL scripts, notebooks, data flows. Orchestrate has pipelines that will run your ETL processes. Monitoring will give you stats on how often your pipelines are running, the status of those pipeline runs. You can drill deep to see each one of the activities in those pipelines, statuses of your triggers, and status of your integration runtimes that are running your data flows. And then manage just allows you to do various management of the workspace. So we go in here to data. I can show you here. That's loading. My machine's running a little bit slow with Skype running. So here, let me close out a lot of these. Okay, so if we look here on the left, we can see our storage account. So this is basically our data lake. We have a few different zones here that I'll explain. So we have, I'll start with raw. Or I'll start with drop. So drop is if you're pushing data into your data lake, you want to put it into the drop zone. So picture this as like if you have an external service that will push data to your Azure storage account, so they know how to talk to the blob storage API. It can put that data into the drop zone, and then you develop a pipeline to take the stuff from that drop zone and put it over into what's considered the raw zone. So the raw zone, that's basically one component of your bronze conceptual area of your data lake. So this will have all your raw data. It may or may not be viewable. This is typically the data you want to hold on to for long periods of time, because if you have to finish building out other curated data products, if you need to rebuild it, you can always use the data that's in raw to rebuild them from scratch. So, but you want to do things like you want to put it in cold storage after a certain period of time to reduce the costs of storage. So if we look in here, so we have AdventureWorks data. So we have, this is all in CSV format. So we have things like customer addresses, information on products, and then informations on sales orders, both the header and line items. So I can come in here. One of the nice things is if I want to see what's in this file, I can simply go to preview. And I can see here that you can see all my products, all the columns within them. So that's kind of nice. You don't have to go out to the storage account or have to run any code to see this data. But then if you do want to be able to use SQL against it, you can just say, okay, this won't let me do. I thought this allowed me to do. I swear that something's changing here because it's in preview. I thought this allowed me to do a select star from this file, but they must have changed that. But then from here, I can create a new notebook with it or a new data flow or a data set. The data set and data flow, that's some of the things from Data Factory. I can manage access, do renames, download it, typical file management activities. So let's try something here. So yes, this is pretty cool. So it wrote a PySpark notebook for me just to load this data and display it. So if I run this, it's going to start a Spark session. This may take a minute or two to run. This Spark pool may not have been started. So with the Spark pool, you can decide how big you want your Spark cluster to be and what size nodes you want to be in it. And then you can configure things like how often you want it to, or after how long do you want it to pause, so it's not running for all hours of the day. It's only really running when you need it. And then here you can, with your notebooks, you can use a variety of different languages, either Python or Scala or some others as well. But I'll come back to that with that spin up. But then, so from your raw zone, then you look at your curated zone, and this will have all your published data products that are that have been curated, they're version controlled, and they're ready for consumption. So in this case, I took all the data that was in the raw zone, and I built out a small star schema from it. So I have a fact table for sales, and then 2 dimension tables for a customer and a product. And so if I come in here, I built these with Dataflow, which I'll show, but it wrote it out to Parquet files. So this is a columnar-based format. It really makes it easy to do SQL on demand and do some other fast analytics because it is a columnar format, so it's easy to pull data out from these files. So I can come in here, and in here I can do select all, select the top 100 rows. So I come in here and I can run SQL against this file. Oh, and yeah, so you see here's all the data, and this is running SQL off a Parquet file sitting in the data lake. This is kind of nice. It doesn't require a database server to be stood up. It doesn't require you. This is all still schema on read. You're not having to define the schema ahead of time to put the data in. So it's really nice for you have these Parquet files. You can just simply do a select from using SQL on demand and get access to your data. So let's jump back over here to see if this notebook finished. Now the Spark session still starting, so we'll give that a few minutes and come back to it. But yeah, the next thing I want to, so another thing, Workspace. So let's take a look at this real quick. So within Workspace, this will have all the, there's 2 types of databases you can have. You can have SQL on demand, or you can have a SQL data warehouse, and that's basically a Synapse data warehouse. So when you create those in the database or in Synapse, you'll see those databases here. So in this case, I have one here called AdventureWorks Reporting. It's a SQL on-demand database, and what I basically did is I created views from the files that are in the data lake, and then I can serve this out to Power BI. And Power BI will talk to this just like it would any other SQL database. But yeah, these views, they're just built off the files in the data lake. I can even show you them here. I'm going to jump over to the develop tab, and I can show you how those views are created. So I have a script here called AdventureWorks DB init. So if we look at this, we just go through and we're writing typical T-SQL, dropping the view if it exists, creating a new view. So we're creating a new view called dim product. It points to the data lake. It's pulling in all the Parquet files in the dim product folder, and it's using that view. And I mean, I could go through and define all the fields and all the columns for that view, or I can just let T-SQL figure it out when it creates the view by using select star. And so all those views now, if you look at the database, they're all in the database, in that SQL on demand database. Yeah, so here that finally finished. It showed or started up the Spark session and ran the query. So it's showing all the data. That's kind of an ugly way to show it, but you can make it a little bit nicer and do display data path. You can run that. This will give you a nicer table. So here, because this is CSV, it's taking a little bit longer to execute. So yeah, here's all the data that it pulled from the CSV. Notice that there's there's no column headers. It's all just it's not reading the header correctly. So I can do basically what I can do here is I can do infer schema equals true, and I believe it's headers equal. Code right. Run that again. Oh, screwed up. What did I do? Oh, that's why. So it's still don't read headers. Header. There we go. Now I read the header. So yeah, this just shows I can use Spark to query the data within the data lake. Anyway, let's jump back over to develop here some. So if we look in here, I have I showed the database init script, and then if I look in here, here's how I build up use data flows to build up the curated data from the raw data. So if I come in here, if I want to build up a customer dimension, this data flow is basically working on streams of data. So let me click on the data flow debug cluster here so I can show you some things in here. But basically, I'm taking these 3 different data sets that are sitting in the raw zone. So customer address, and address. And I'm joining the address. I'm filtering so it only uses the main office address. I'm selecting the columns out. I'm doing a little bit of typecasting on the columns, and then I'm writing it out to the curated zone. But basically syncing it to the curated zone as a Parquet format. So if I come in here, so customer, that's a source data set. So I have a data set defined. That's called sales LT customer raw file. And if I open that up, I can see some details on it. it's text, it's in the raw zone, it's going to my data lake, my this link service, and here's the path to the data, and some other, it's comma separated, some of the basic default things for a CSV, treating the first row as a header.
Derek, what's that format you mentioned, the Parquet format?
Parquet?
Yeah.
Yeah, so Parquet, it's a binary format. It's columnar storage, so it's column based instead of row based, and really it also has the capability to bake a schema inside of it, and the schema is a little bit more than what you get from a CSV file. But since it's columnar format, it makes it easy to do these serverless queries and being able to use Spark on to operate on those on that data that's sitting in those files.
Is it kind of becoming a standard, like an industry standard, or it's more specific to Spark and Databricks?
I believe it's an industry standard. It is heavily used within Spark and Databricks, and of course, it's in Dataflow. Dataflow is really just is really using Databricks and Spark under the covers. So so yeah, it is kind of, I don't know whether it's a formal industry standard, but it's an industry convention to use Parquet for these types of big data solutions.
Okay, thank you.
But yeah, so different options for source. I can pull in a list of files if they're partitioned. Mine aren't partitioned, it's just a single file, so I just specify that single file inside the data set. It's detecting the type of data that's coming in, so I can come in here and say, well, modified date. It's not a string, it's a timestamp, and then it's a timestamp, and then in here you can specify the format of that timestamp. So that's one of the things you can do when you're bringing in the data. And then you can do joins. So here I'll do a join for customer address. So I'll do the left string will be customer, right string will be customer address, the type of join on customer ID, and then same thing for pulling in the customer address. Yeah, so now since my cluster is ready, I can come in here and I can start previewing some of this. So I can come in here and say data preview, click refresh, and I can see how my source data looks when it's sitting in the data lake. And then each step along the way, I can examine the data. So as I'm developing this data flow, I can look at the data preview to see the results of this transformation. Taking a while to fetch data. So yeah, so here's all of my data that's sitting in source right now. And then, when I get to like select columns here, select columns, I'm only going to pull out certain fields that I want, and I can map them to the name I want to call them. So it's like in SQL when you're doing select this column, and then you're aliasing it as another column. So that's all this is doing here. But when I'm done, I can come in here and say, okay, let's take a look, make sure I did this all correctly, and it all looks okay. Taking a while to fetch data. I'm not sure what's this is using a debug cluster behind the scenes, so in some experiences the bug clusters can be a little buggy at some points in time. But yeah, so here's all the data. I alias some of the columns. And then from there, it'll run another. I have another transformation here that typecast the columns, and then I can sync the column into another data set. And that's in Parquet format. So if I open this up, I can say, okay, this is going to curated zone and putting it in the AdventureWorks DWH/dim customer folder. which I can come over here and see. One of the nice things about Synapse is I don't have to go to another tool like Storage Explorer or even the Azure portal. I can come in here and I can see like, oh, here's my customer data, and here it is in Parquet. And then I can come in here and run a query on Parquet to make sure that the sync actually worked correctly. And this success file here, so what Spark will do is I have it configured just to do default partitioning. So it will partition the data accordingly and output multiple part files for your Parquet files, or for your data set. So you may have a data set that spans multiple Parquet files, but each one of the data inside of it is partitioned in order for optimal performance. And you can configure that. So if you come in here, you can decide how you want to do partitioning. So you can decide like, okay, just use the current partitioning. You can even output it to a single partition, or you can set the different partitioning. So you can do, a round robin approach or a hash approach. And there's different options here on how you want to do this. And each one of these has certain use cases that you may want to use when you're building out the data products and how you want them partitioned. For this demo, I just left it as use current. So, but yeah, I have data flows for each one of the different tables that I build for this data warehouse files that I have. So here's one for sales where I take the order header, the detail, and the product source data, and I start building out a fact table from it. And I sync that fact table down to the curated zone. And then same thing with product dimension. And then the way this is all orchestrated is if you come over here to the orchestrate tab, I have a pipeline here called build reporting files. And this is just what it takes. It takes the data from that raw zone and it builds up. It runs these data flows in order to build up the dimension table and the fact table. So really, this is just calling out to the data flow that we created. So that data flow was product dimension. So it's going to call out to there. And then when it's completed, it'll go to build customer dimension and finally the fact sales table as well. So this will run sequentially. I can take out the dependencies here and I can run these in parallel if I want. So really this part of Synapse is what's considered Azure Data Factory. So Azure Data Factory is still a service within Azure, but they integrated it within Synapse. So basically what this allows you to do is, let me show a new pipeline here. So there's different activities that I can do in here. Like I can just do copy data. So if I just need to copy data from a source to a sink, I can. So if I need to do let's say I need to copy it from a table in a database, I can just choose that table. I can give that table a name. Maybe it's sales LT products. Okay, so it'll pull it from that table, but then I can sync it then to. Let me create actually, I can just sync it to this raw file here. Okay, so file name, I'll call it saleslt.csv. Oops, saleslt, what was that? That was products. Since I already have one in there, I'm going to call it products 2. Okay, so that'll copy data from the database and put it into a raw file, and it'll put it in the raw zone. So I can take this and I'll give this a better name. Copy table data. Validate it, make sure it works right. No issues, and then I can just simply run debug. And it'll execute that pipeline. Oh, failed. What did I do wrong? That's weird. Object reference not set to an instance of an object. Let's try that again. Maybe it's just a bug. Oh, that's a weird guy. Let's try publish it first. It's taking a while to publish. There we go. Now I'm just going to try to trigger it. So here I can jump over to monitor since it triggered it. And I should be able to see that pipeline. Yep, that pipeline started running. It's a manual trigger showing in progress. I can come in here and I can see the status of each activity. So right now it's in copy table data. And I lost my pipeline run for some reason. That's weird. Oh, it failed. How did it fail? This is bugging me now. Oh, it can't connect to the SQL database. I have something that I need to fix in order to do that. I'll come back to this if we have time. Basically, I don't have the proper permissions to contact that SQL database configured between the data factory and the database. So I'll come back to that. So let's see, what else can we take a look at here? So we built up the data warehouse with the data flows using the pipeline. So now I can do some things like, let's say I can have a notebook in here now. So if I'm a data scientist, I can come in and I can do I can just start writing Jupyter notebooks. So, and some of this we've seen before by by opening it up just from the Data Explorer. But so here, I just want to query for all the data that's in the product in the raw zone. I can do that. It'll display all the list of products. But then I build out something just something simple where it shows the top 5 products and their name, the top 5 selling products and their name from that curated zone. So if we look, I'm using Spark to read a Parquet file, and here's the path to the Parquet file. Now, this is using a URL that's it's just a Hadoop-based data reader. So ABFSS just means it's actually Azure Blob File Storage Secure, and you're giving it the container name, which is curated at, and then the fully qualified domain name of the storage account, and then the path. So I have one here for the sales. So I have a data frame for sales, a data frame for products, and I'm coming in here and I'm building up a new data frame where I'm taking the sales data, joining it to products using the product key. I'm grouping it by the product alternate key. I'm aggregating it to build up a sum of the sales amount. I'm aliasing that column, and I'm ordering it by the total product sales amount, descending, and I'm using the top 5. And when I run this, and my Spark session decides to fail. Due to core capacity being exceeded. Interesting. So looks like there's some capacity issues going on where I can't start up Spark. That's odd.
If that's not possible, did you plan on going over ARM templates and how to create them?
I can show something on how to do it. I might have to dig out some ARM templates I have, but yeah, I can show that if everyone wants to see that stuff. So let me see here. So we have, see if there's anything else I want to cover here. So with the Spark pool having an issue, so one thing I can do is I can show, let me go to develop here. Since the Spark pool didn't work, I have a SQL script that does the same thing, as I wanted to show how SQL worked. So yeah, same thing here. I'm just really pulling from those Parquet files, and I'm just running some SQL to get the top 5 selling products. So if I run that, here are the top 5 products, their total sales amount, and I can. It's kind of nice here is I can do a chart, so I can come in here and say, okay, a column chart. Category column is product alternate key. So if I'm just in here doing some ad hoc analysis, maybe I'm a data scientist or doing someone else just kind of coming in here doing some quick one-off analysis. I can take this and save it as an image to send off in an email, or in a table format. I can export the results as CSV, or so it's kind of nice they have that. Let me just check. Let me check this again, just to kind of give you the what this looks like. Yeah, they're definitely having some issues there. Core capacity being exceeded. Yeah, I'm not sure what's going on there. Anyway, so that's, I mean, really, that's all for Synapse. I kind of like it. I think it's a good direction. You're kind of they're bundling everything into a single experience, so you really don't have to leave. You don't have to leave this tool to do a lot of things. Well, one thing else I wanted to show is, okay, so we have this database here now, this SQL on demand database. So one thing that's nice now is I can come in here to Power BI, and I pulled in all this data, and all I did was use a SQL database connection. So I have this data now, and now I can run this. I can run this Power BI visualization using that SQL on demand database. So it's kind of nice, where you don't have to have a full-blown database running to do some of this analysis. It becomes a cheaper option for organizations. Okay, ARM templates. Let me see if I can find some here. Hang on one second. Is there any other questions while I look for some ARM templates?
So just to think, like, how does the iterative approach look like, or how does the evolution of, for someone starting in this space, right? They don't have a lot of assets in the cloud or in the Synapse world. Probably they have a few databases and a data warehouse. So how have you seen the customers kind of gaining that maturity, or what's their evolution like? Uh,
So what we've seen is, some organizations they just take. We see a lot of it with like some older or some other technologies like Teradata, where Teradata becomes expensive to maintain. So users are pushing, they're basically doing a one-off data migration up to the cloud, and they're putting the data in a Synapse data warehouse. So they're doing that, and then they're building they're building pipelines and such up of that to do further analytics. In other cases where organizations, they have these databases sitting around, whether they're cloud or on-prem, and they're just using Data Factory to pull them into the data lake. And maybe they're only pulling out a subset of the data that they need to satisfy a use case. But they're really just doing a subset of the data that they need. There's some, we've seen some organizations where they pull all kinds of data into raw, which is okay, that's fine. But then they want to try to curate all the data into some data product that they're not sure is actually going to be used by a consumer. So that's why it's good to push as much data into raw, but then you want to kind of hold it there until you have some analytic use cases on the other side in order to drive out some useful data products that can be used across the organization.
I have a similar question, sort of thinking out loud. Is it because the data lake is so unstructured, it has the different zones, that if you were to use an iterative approach where you go use case by use case and you pull in the data that you need for each use case, that the the data lake is so dynamic that you don't have to figure out all of the architecture and the database schema beforehand for all of the features. So you can basically just build on the data lake as you have new use cases. Is that the idea behind the data lake being so unstructured? It lends itself better to iterative delivery?
Yes, that's exactly it. So you can get that data into your raw zone without a lot of effort. And then once you start getting those use cases, then you can take from the raw zone, you can start building out these curated data products. And then you can get into the curation process then to serve it out to your organization. And from there is where you start building out like version 1, version 2 of your data products. So yeah, it really helps that iterative approach where if you had a data warehouse and you wanted to put data into your data warehouse, well, you still have to find ways like, okay, how am I going to get the data to me? And maybe it's files, right? Like maybe you see where some data feeds are FTP. So there's an FTP site, and then from there, that FTP, you got to take that data, you got to analyze it, you got to figure out what table structure to put all this data in, and then you have to transform it and load it into the data warehouse, which that takes a lot of time. Where with the data lake, you just simply say, okay, well, I have this data coming in from FTP. I'm not quite sure what to do with it, so I'm just going to keep storing it in the raw zone. And that's not a lot of effort to stand up. That becomes very simple. But something like Data Factory too, like in Synapse, you can just put in a pipeline, put in a copy command, fetch your data from your FTP site, copy it to raw, and then when you get use cases later on, then you can work on further aggregate or further curating that data. Make sense?
Yep.
Okay. Can everyone see my screen? I may have to zoom in a little bit here. Okay, let's see here. Let's see if I can get rid of this. Yep, perfect. So this is a kind of an all-in-one ARM template that this basically stands up a few different things here. So it has a data lake storage account. It has a Synapse workspace. And here these are the variable section. I'm just here defining some of the variables that I need to actually set up the resources. So the Synapse workspace. in this case, I had a SQL server because I needed to temporarily store something coming from. In this case, I was using Dynamics 365, and they have a tool in there called BYOD, Bring Your Own Database, where it'll just dump your entity store and all your data to a database. They do have they have newer capabilities for Azure Data Lake, but I needed to try something, and so I spun up a SQL server in order to dump that data. So this ARM template basically sets up that SQL server. This will be deprecated. We can use a data lake now, but yeah. So I come in and I create a storage account using the variables I defined earlier. So what makes it an ADLS Gen 2, which is it has a hierarchical file system, is by setting this parameter, is HNS enabled. So that's hierarchical namespace. So that allows that basically allows like a file system type view on top of an Azure storage account or Azure Blob storage account. Network ACLs, we have a set of IP rules, and then we have a bypass for any Azure trusted services. That's some things you see in organizations a lot. And then I go in here and I create the various containers. And I had 4 different containers. So I had, it's up here in the variable section. So I have a drop, a raw, a curated, and a temp. So that creates all the containers. What else? I have a storage account for logs. So anything from, when you enable a database, you can make, you can do advanced threat detection, and it'll output logs to a storage account. So I have that configured as well. I'm using some data factories in here, which is, you're free to use data factories with Synapse. One thing that Synapse doesn't offer yet, but they're working on that, and it's because it's still in preview, is there's no Git integration with Synapse. So in this case, for this project, we needed to really have that Git integration to deploy to other environments. So I spun up a few data factories to help us out there, but I'm still using the data lake that Synapse has, and I'm still using the SQL on-demand capabilities as well. So yeah, I'm in here. I'm creating a data factory, and then here's where I actually create the Synapse workspace. So I create that workspace. I give it like a default data lake storage where that needs to be. And then I need a SQL admin login for any SQL pools that I create. So I specify that there. And then administrators, I tie my Azure AD account as administrators on this workspace, so that when I create SQL pools and I access them through like SQL Management Studio or other tools, I could just use my Azure AD credentials. I put firewall rules on the Synapse workspace, so restricting which public IPs can access that Synapse workspace. I had SQL pools in here, but I didn't need them, so I just commented those out. But if I wanted this to spin up a SQL pool, so this would be a SQL data warehouse or an Azure data warehouse, I could, here's the templating to do that. And then for SQL Server, I'm going to be deprecating this, but same thing. It looks much like the Synapse workspace does. And then I create a database in the SQL Server, and that's what the templating that configures that. Then I have a bunch of role assignments, so you'll see that I have to assign RBAC between the data factory and the storage account, the data factory and the database, and then Synapse and the storage account. So there's a lot of different role assignments that need to be put in place. So what I did is I defined, I basically do a loop over role assignments, and I loop through the ones that I need to assign for data factories and the ones I need to assign for storage accounts. And that way I don't need to keep repeating this templating all the time for each storage account or for each data factory. I can simply, I have variables up here that I just loop through for role assignments. This is using the managed identity. So when you create a data factory, when you create Synapse, there's a managed identity created for you in Azure AD, and you can use that to govern what that data factory or what that Synapse workspace can access within Azure. So for like the storage account, Synapse can be a storage blob data contributor on that data lake. So it can do read and write data within that data lake.
So I'm brand new to ARM templates. Is an ARM template the same as a gold disk if you wanted to spin up an environment? All of the code, all of the credentials, all of what's necessary, all of the resources is compiled. Is that the same as what an ARM template is?
Yes, you can think of it that way. Now, it's not going to store your credentials in plain text. You have to rely on like a key vault or something to store those securely. But yeah, I mean, you can think of it that way. So you can have an ARM template like this one stands up the Synapse environment, the data lake, and anything else that I need for that data platform. So if you notice here, I have an environment that I pass in, and it's dev, test, QA, or prod. So what I can do here now is I have this template. I have a parameter file, which I can show you that specifies parameters for each one of these. And I have one for dev. Okay, so here's all my parameters for my dev environment. Now notice SQL administrator password. I don't have a plain text password in here. I reference a key vault and tell it to pull it from the secret name SQL administrator password. So I have all that there, but then but yeah, so this template, this will set up everything that I need. And I could put this into a DevOps release pipeline. I could run this and deploy this via command line. And this will set up the entire environment and it'll be ready to go without any interaction. So this really is the concept of infrastructure as code.
Yep. You can think of it as your infrastructure spec as well. So you provide the spec and just say make it so, and it'll just make it a declarative specification. Yeah.
Mm-hmm.
And then remember how I said that a data factory has Git integration. So if I'm in a data factory, oh, I didn't pull that. I'm sorry. I have to pull that data. Yeah, I'll have to pull that. I'm sorry, but kind of a false start there. But yeah, so Data Factory has Git integration. So anything you do in Data Factory, which would be if I'm in Synapse, it would be anything in this orchestrate section. So any pipelines or any data flows, if I'm doing this within Data Factory, I can tie that to Git. So all my changes will be going into a Git repository. And it has support for all the good practices that you do with Git, like you create a feature branch, then you can create a pull request from that. It can be reviewed and then merged into master. And then it can only be published from the master branch. So if you put policies on your master branch where it has to go through a pull request review, then you're really protecting that data factory from being from having like unreviewed changes going to it. So that really becomes powerful as well in your DevOps with your DevOps processes.
Mm-hmm.
Anything else? I kind of covered everything here from a Synapse perspective. Let me run this again, see if I can start a Spark session. Well, it looks like it's better luck. So while that's running, I'm trying to think if there's anything else. I don't think we covered manage here a lot. Let's
I'd be interested in monitoring if you were just the analytics side, because we're getting into some customer adoption items, and so anything on monitoring would be helpful.
Yep. Yeah, for some reason, my browser is locked up here. I don't know what's going on. I want to show monitoring here. Try something here. Yeah, so if we look from here's the Azure platform. Here's all the resources that I used for this demo. So I have a Synapse workspace. I have a data lake. I had I'll consider it an external SQL server to host the AdventureWorks data from like a transactional database. And then I actually created a SQL pool, a Synapse SQL pool that's that data warehouse. I'm not using it right now, but I have that created. So here's all the resources that are set up. And I mean, even from a ARM template perspective, if you wanted to get started and you didn't want to do a template from scratch, you can come in here and say export template, and it'll generate the template for you. And this will at least give you a starting point to to build out that template. But anyway, I wanted to come over here to monitoring. I'm just going to open up. Yeah, I apologize. I don't know why this is taking so long to load. Yeah, I'm not sure what's going on here. And any other questions while we wait for this to come up? Well, here it comes. Maybe not. Yeah, I'm not sure what's going on.
I'll just ask one, like, how about the security aspects? Like, how are you working with your customers on those, moving all of this data into cloud and staging?
Like when you say security aspects, like anything in particular, or just in general?
Yeah, kind of approach to security, starting from data encryption to moving the data over there, residing it in cloud, and then I don't know if there are any governance or checks and balance in place once it is.
Yeah, so I mean, there's a bunch of different things that go into this. The first thing is that your data lake is all the data stored in it is encrypted at rest. So that's one of the first things. We can either do customer managed or Microsoft managed keys. And then the second, as far as the data movement, so if you have to move data from an on-premise database, you need to have this component installed on that network on your on-prem network that has access to that database. You need to have this component called an integration runtime. And basically, it's a little piece of software that it basically pulls Data Factory or pulls Synapse to see if there's any jobs waiting for it. So it's all it's doing is outbound HTTPS. And when it sees it has a job, then it will execute the job on that machine. So if you need to pull data from an on-premise database, it'll run the query, and then it will copy it to the sync location, whether that's another database or if that's Azure Blob Storage. So in the case of Data Lake or Azure Blob Storage, it will convert the database query to result in either a CSV or a Parquet file or JSON, and it'll copy it up to Azure Blob Storage. And it'll do that, it can do that through either like a public network, in which case you'll have to whitelist your, allow your organization's public IPs into your storage account. Or there's even scenarios where you can leverage your ExpressRoute or VPN. So from that aspect, that's how it gets data from on-prem. It's not Data Factory actually making a request down to the database. It's delegating to an agent running within an organization to make that query and copy it to a specific location. And then, once it's in a storage account, then obviously you have certain RBAC that you can apply. And you can also do governance policies around that storage account. Like you can force people to, whenever they create a storage account, that they have to turn on encryption and they have to have a firewall control or an IP address control list on there as well. And then from the storage account, then you have RBAC. So you're controlling which groups or users or services can read data from the data lake, or who can actually write data to the data lake. And typically for something like a raw zone, you typically don't let data scientists or end users into those. It's really for your development team to have access to that data or services. In some organizations, they don't allow access to the raw data in production. Like you're not allowed seeing that. So there's different RBAC you can do for that. And then then with RBAC, you have typical best practices around there. You don't assign specific users. You really do groups, and then you can access it through group management, which Azure AD has some self-service group management as well for doing that. And then things like Data Factory and Synapse, you can control access to those with RBAC. The link services, so when you're in here and you have links out to, like I have a link service here for the data lake. So this is all managed identity. So this contacts the data lake through a managed identity. And here's where the integration runtime comes in. When it says auto resolve integration runtime, that's really the Azure controlled and Azure managed integration runtime. And then, and then same thing with Synapse. If you're talking to the data warehouse, then there's security around that. You have your traditional SQL, your SQL type security where you can have Windows logins or Azure AD logins, but then you can also have your SQL Server logins as well. Is my screen still sharing? Skype just did something weird.
Yeah.
It's not sharing. I see a black screen.
I'm sorry.
It's back.
Okay, good. Yeah, Skype did something weird. It's like it crashed or something. Anyway, so yeah, that was, it was a lot there for security, but really it's just leveraging a lot of the best practices that Azure recommends, for security, especially around networking and identity.
Okay.
So on to Monitor now. So it took a while to get Monitor up, but yeah, so in here, you can see the status of each one of your pipeline runs. And then something I just noticed actually in here is that Synapse doesn't have the ability to do alerts directly within here. When you run Data Factory, you can create alerts within the Monitor area. So you can, is that in Manage? No, it's not even in Manage either. That's interesting. But anyway, there is another way you can do monitoring. You can use Azure Monitor to monitor these pipelines and to do alerts on them. But then, so you can manage, you can monitor pipeline runs. You can come in here and manage or monitor the different activities that are inside your pipeline. So it really, and then what's kind of nice too is that on each one of these activities, you can assign a refresh or a retry, I should say. So if it fails for some reason, you can do a retry, and it'll retry it up to a certain number of times you specify in order to and to get around any, like sometimes you have blips that sometimes it just things air out. So you can do the retry, like that Spark thing before. If it couldn't acquire a Spark session because of capacity issues, you can set it to retry and hoping that it avoids that, and hoping that avoids the Spark session timeout. But yeah, so you can come in here and you can monitor the Spark application. So for some reason, it's showing that ad hoc notebook still in progress. But yeah, you can come in here and you can see it gives you a lot of information here about the Spark pool and your jobs. Same thing with SQL requests. Request history coming on demand soon. Another one of those preview things. Only running requests can be seen at this time. So lots of things with this being still in preview that aren't quite there yet. I believe what you can do with Synapse is alerting here. Looks like it's not giving any of the orchestration type. Yes, it looks like they need to do some work here yet on the alerting from Synapse, because I'm not seeing Data Factory. You can set up alerts on the pipeline for failures, either at the trigger level, the pipeline level, or the activity level. But I'm not seeing them here unless it's over. For some reason, it's not responding again. I'm wondering if it's my Skype. My browser seems to be locked up here. Well, maybe not. There it is. Yeah, it doesn't look like there's any alerting here either. Properties, annotations, but no alerting. Okay. Sorry I couldn't have a little bit more for you on monitoring, but yeah, you'll be able to monitor pipelines once it's in general availability. I would imagine. I mean, they have that capability within Data Factory. I'd imagine they'd have it in Synapse.
Okay.
Any other questions?
Yeah.
Derek, when will I guess Synapse be out of preview?
That's to be TBD. We typically don't hear about when things are going to go into general availability. So yeah, it's TBD. It's been in public preview since about September or October of last year.
Okay. Are there any other questions? Doesn't look like in the chat.
Okay, I was going to turn this back over to Eric. He was just going to kind of finish up with a few other slides. But yeah, thanks everyone for the participation with the demo. It definitely helps when there's some questions being asked. I thought we had some good discussions. So thank you guys very much.
Thanks a
Thank
lot.
you.
Thanks, Derek.
Yeah, thank you, Derek. I think that was very thorough. And, one thing, I mean, yeah, this was a case study with a grocery client of ours. We can't disclose their name, but Derek was engaged with them. We've done a number of projects with them. They're a leader in the Northeast in terms of profitability and customer satisfaction, but they really did want to take a closer examination into, getting to know their customer. Right? They had all of the data points, um, but they really didn't have a clear, isolated view of that individual customer. So the customer data lake solution and platform really helped them to gain the insights from all of their different data points, being customer behavior, what their buying habits might be, some of the outside trends that impact shopping decisions and everything like that. Um, and now looking forward in the future, right? They're well positioned to build upon the platform that exists to help drive further insights um, across their enterprise.